It's working, sweet. Well, hey, good morning, everybody. Thank you for coming out to the Actuators and Ewoks presentation. And I'm going to go a little further than just actuators with this because I've had a lot of people over the last 3 days looking at R2 here, my droid, and asking how I did the animations with the arms and the zappers and things like that. And so what I just passed out was a gummy bear pack with a 25% off coupon from Actuonics. Actuonics got a hold of one of my YouTube videos and approached me and said, hey, you know, we want to get involved with the builders, obviously, because they make micro track actuators, which work in our build. And I said, cool, you know, what do you want to do? And they sent me some coupons and some other stuff, and I'm going to talk about that today a little bit and tell you how I use those in the Droid. But first, we're going to talk about, you know, what these things are. So, actuators and Ewoks. First of all, let's jump through. You know, what is an actuator? Okay, well, we all know what servos are, but a lot of people are like, well, what's an actuator? Well, actuators, whereas servos rotate, actuators, you know, they push and pull stuff. So when you see the zapper coming out of a bot, that's an actuator pushing it and pulling it. They're called linear servos a lot of times. So when you shop online, if you're looking for stuff, you see like servo, linear servo. Linear servo is basically an actuator. There are a couple different ways that they make actuators. They make linear actuators, which are the push-pull, and they make slide track actuators, which are kind of like a worm drive with a little track. It rides the track up and rides the track back, and you can control the distance that it travels. Or it may have limit switches on either side, which say, hey, when you get to this point, stop. And when you get to this point, stop, which is what I use in my application for the zapper. I don't have to tell R2, hey, I want you to move this thing so many inches and stop and then zap. I just turn it on and the current feeds the zapper all the way out, and when it hits the limit switch, it stops. And I know how long that takes, so I put a little sleep command in there. It says sleep for 3 seconds and then zap it. You know, and then I do the same thing in reverse to bring it back in. So it's very, very simple to make it work. They come in specific lengths, so you can get them like 200, 300, 400 millimeter lengths. The one I'm using is a 100 millimeter length because when I measured it out, it was the perfect length to get that zapper out the right way and not like bump into somebody by having it go out too far because mine actually zaps. so I don't want someone to walk up and go, hey, it's a really nice thing, and you get hit in the leg or something. You know, with it. They can handle all kinds of different voltages. You have servo actuators that can run on 5 and 6 volt runs, and then you've got other actuators that can go like to 12 volts, and you can even overvolt them a little bit, but not for a long period of time. I mean, you want to go past the spec on it, because if you overvolt it, you'll just fry it like you would a regular servo. So you don't want to do that. And they can be more durable than standard servos because they're on a worm drive, and a worm drive setup is, who has Darren's dome motor? It's basically a seat motor from a Chevy. You got that? Okay, it's a worm drive, right? It runs and then it runs the track. So a worm drive is that. It's basically on a threaded rod. The rod's turning and it's riding the rod. So you can tell right away that it's going to be a little stronger than a standard servo, you know, which is swinging out because it's got the leverage, you know, on it. So that's the difference there. So how do they work? Well, as I said before, they behave like servos. I already touched on the limit switches, which give you fixed points of travel. They usually run on H bridges, or you can use pulse width modulation control like you would a normal servo. H bridges, they give you full motor control that you can control the speed and you can control the distance and the travel and everything. And typically if you have an actuator that it does not have feedback on it like a servo, you'll need an H bridge to tell it when to stop or when you want to turn it on and turn it off on there. So that's one thing with those. And this is your typical L298H bridge. It's actually very small. I'm going to pull this out and show it. It's that's it on the back here of this block. Since I have this in my hand, give it up for Kevin over there because he donated his upper charge bay hinge to this, and I got Actuonics to throw in money on the actuator. And then I built the 3D printed bracket and the H bridge and all the zapper stuff, and this will be in the auction tomorrow. So if you want to put a zapper in your droid, this is the carrier that I have in mine. It's actually nicer than mine because it's been refined. But thank you, Kevin, for the donation. And this is going to go in there. So bid up on it for St. Jude. And I'll be talking about this a little more in a second. So anyway, You can use the 298 bridge. It's very inexpensive. It's like less than 10 bucks. I think you can get them like super cheap. Well, you can't read it, but what are the specs? Well, on actuators, you've got push-pull, the specs on those and how much they'll actually handle for torque and stuff, so you don't want to like go over it. For our purposes, the T16 model and the L16R model from Actuators is perfect. It's a 100 millimeter throw or 100 or 200 millimeter throw or 140 millimeter throw. And on R2 here, when his CPU arm is extending, he actually, let me jump in here, when he extends his CPU arm, what he's doing is there's an L, I don't know if you can see this very well, but there's an L16R that's 100 millimeter that's pulling down on an L bracket that's causing the up on it. And then there's a 140 millimeter actuator inside that pushes the probe out. And I measured that out because the probe, I wanted it to extend a little longer than the chassis. And I just installed it inside the cylinder on there. So they come in different lengths and different powers. The T16 comes in a 100, a 200, a 300, and the L16 comes in a 50, a 100, and a 140 millimeter throw. So if you're doing the CPU arm, the 100 and the 140 I think is the best one. And if you're going to do the zapper, I think the 100 millimeter is the best one, for running through. And on my build log on the first page, I have hyperlinks to all the tutorials on how I did mine if you want to try to replicate that or come up with your own, which is what Ian did, wherever Ian is. Is he in here? Okay. Oh, hey, all right. Ian came up with a great idea. He created basically a track actuator out of a continuous rotation servo and a 3D printer gate, track that he put in there. So it's basically the same concept. So track actuators. So let's jump back over and you'll see now I'll mess it up. There we go. Move. Ow. All right. Serves me right for jumping over to different things. Okay, so now what do they cost? Well, you get all kinds of different prices on track actuators. The model ones that we run are about $70, $80 for general animation purposes. But these guys can go up into the $1,000 plus range on these things. Actuators, they use them all over the place, industrial robotics, all kinds of stuff. If you have a 232 conversion in your droid, you're using actuators to raise and lower the center foot and pull on the carriage to get the thing to tilt. So that's what you're using those for. That's why we have them. So they're very, very nice to have. And then what can they do? Well, this is a picture of my droid with all this stuff extended, and then my welding arm that works on another L100 that actually pulls it down to kick it out. And so we can use it for push-pull and then different travel. Let's see here. Next one. The last thing that I have in this, because I wanted to just kind of show how this works more than talk about it and discuss it so I can show you software, is they also have a little small mini actuator. It's about this big, and what it's great for is if you're doing like I have a deadbolt in the back of R2, and it's running on an Arduino, and it runs in a knit script that basically pulls the pin to get inside, and if you hold it down long enough, it extends the pin back into position. So you can use them for little things like that too in it. So they're very useful inside our hobby and what we do. And I got turned on to them about 2 years ago just because I was looking to get the CPU arm to work. And I just started looking around on what pushes and pulls things and did the research and just started buying it. So they were nice enough to throw that out. It's just something that you can put in your droid, you can enjoy it. The kids really dig it when stuff comes out of the body on the droid. And you can use it for anything. You can actually use it as a lifter too. So if you want to take something and shoot it out the top of the droid, you could put that on a track actuator. I mean, ultimately, if you're fortunate enough to have Doug's a lifter rotary kit, in there, that's he made an actuator basically with a 6-volt motor and a worm drive in it, and it's beautiful. So it's a piece of art. It really is nice. But essentially, that's what it is. So this is another solution to getting things to come up out of your droid and get things to go out up on a horizontal and a vertical plane on it. So that's what it is. So I'll open up some questions, and I'm going to do some demonstration work on it. And I've had a lot of people this week asking me about my operating system that I use. So I am slaving into him on this so I can actually show you how I can control actuators and servos with the setup that I have on there. So do we have any questions about actuators before I get into the other part? All right, it was like get on the other part. Cool, we got it, okay. So I'm gonna jump out of here and we're gonna go to another land. Okay, you got this up? Yeah. Okay, so this setup, the setup that I use is by the Easy Robot company, and they make something called an EZB V4/2 microcontroller. What's unique about the microcontroller is that it is a Wi-Fi microcontroller, and they do have a way to plug it straight in. You can actually use one of their DIN cables and plug it into the USB port on your computer or on something just to do a direct connection if you wish. But it really works best over Wi-Fi on the two. So inside my bot, I've got I have a nano router in the dome, and I have one in the body, or a nano router in the dome, and I've got an EZB in the dome and an EZB in the body, and they are talking to each other. And they're also talking to a Surface that I have in here that actually runs this software. For the demonstration today, I have slaved into him with my laptop because I can use anything I want to actually control him, whether it's a Surface or a laptop. So what's cool about that is that I can sit at my desk and use a mouse and play with all the goodies in him and not have to worry about, gosh, have I got him charged up right or what's going on. It has a really fast transmission speed. It's very, very efficient, and it's very easy to get it to do the things you want it to do because it's very visual based. It's not just lines of code that you've got to decipher and go through. It's actually very visual. So what I wanted to show you was how visual it actually is. So what you're looking at here on this piece is the Easy Robot app has three basic screens on it, three desktops. The first desktop that I have is a sound file. So this is every sound file in the club, and they're all connected, and I can play them on cue, and I can tie them into sketches on here. The second desktop is a desktop that I have that I wrote all the different script animations on it using what they call a script manager to actually do. On this one, wish you could read it better, but this one says like body animations. This one is hollow projector lighting. This one is independent servos, and then this one here is magic panel. And once I got hold of all the code and got the help from people here to get these going, specifically Ryan really helped me on this to get the magic panel fired up right and get it going. I was able to incorporate it into the build. And so this little guy here is what you call a movement panel, and this is what controls. Yes, sir. Oh, yeah, hold on. Yeah, turn them around here. Okay. So, is that better? Okay, stop on a right. So the movement panel actually controls the H bridge that's on what I just showed you on the Zapper carrier. So I can open and close it using that movement panel. If you scroll down, I have something here, and this is what I really want to show you. It's called an auto position window. And the auto position window, when you, if you ever put a servo in your bot and you're playing around with it and you're like, man, I got to set this on 90 and that's my origination point, then I got to through and tune it. This was the big wow factor for me. Let me tell you, I am not a coder. I didn't know anything about this when I started reading 5 years ago. And when I first started putting our two together 2 years ago, I still didn't know much about it. And I was scared to death about it. I was happier cutting into the dome than actually thinking about how I was going to make it all work. It scared me to death. Because cutting into stuff, easy. Drilling holes, easy. This stuff scared me to death. So this is what actually got me not scared. The auto position piece inside the software has the ability to do all kinds of fun stuff. So check this out. So I loaded this graphic of R2, and then what I decided to do was click on this. Check it out. All doors open. Bink. Okay. So all doors open. So basically what this is a graphic of all the servos on the front of R2 and the digital positions that they're plugged into on the EZB board. So here. So when you're doing this, you can actually pull up the microcontroller and you can look and see, okay, where's my servo plugged into? Well, in this case, it's plugged into position D0, which is on the upper right-hand side. And then I was like, okay, and once I got it plugged into there, what do I want this to do? Well, this is where your travel piece is, where you can adjust the actual servo position. So I just remembered that I have to do something here real quick. Hold on. Because if we're going to play with doors, we need to put R2's toys away. So let's do that. Dun, 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 dun. Na, 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 na. There we go. So, all right, let's put it away. The reason why is because when I start playing with door positions, it'll try to shut on that CPU arm. And that would be bad, yes. So let's go back here. So now we'll go back to this auto position thing. I know. Hold on. Yeah, we're going to mute you. All right, good deal. I know, we're going to mute you. You're not happy, I get it. So check this out. So back to the auto position thing. So here's our R2. All doors open. Okay. We got real-time port edit. Now we can play with this thing. So let's see here. Go back. We're going to go here. And real time. All right. There we go. Are we open? Oh, we're open. Oh, gosh, he's quiet. Is he open now? Oh, yeah. Okay, sorry. I forgot to tell you that I adjusted the speed controller on the open and close in the adjustment. So normally I hear him slap closed and slap open, so I didn't think he was open. So when he's open, it's saying that on the left and right door, I'm using ports D21 and D0. And then to adjust this, I can simply grab this guy and slide it. So like, is it moving? Yeah. How slick is that? So this is how a newbie like myself did his robot. I found a platform that allowed me to play around with it and adjust it and everything. So, that's it. So I can control this thing. I can say, where's the open point? Where's the close point? And I think 142 is where it was before. I don't know. I'm just not going to save it. So we'll go back into it. So that's how you can do that. So there we go. So that's how you can actually adjust these things. Now I did it all over. So like you can do all doors closed. Is it all closed up? Yep. Okay. And then we're going to go back to another one. Let's do dome positions. Same thing. I loaded an image of the top of my R2 unit because I wanted to play with all the doors. So I popped all the doors open. And then what I did is I labeled them. So now those are all the servo and dome positions on the top of the dome. So all different digital ports, just like before. Go through. Now this is the EZB that's in the dome. So let's look at this one here, right? Let's just pop this in. So boom. So D0 didn't open up because I fried that one yesterday. Let's do D1. D1 here, that's a dome panel 2, right? So that's the orange shows what it's plugged into because that's what I told it. And then what we can do here is we can play with this. So the number was 86 value. So I can now wiggle this and tweak it to where I want it. So this is the Easy Robot Controller and how I did the droid. The entire droid is set up this way. Yes? Oh, sorry. Yeah, hold on. So here's the top dome. You can, yeah. So I can do that too. So that's the top dome.
So you set a value and that's where it's going.
Yeah, that's where it'll be. The only thing that'll throw it off is if you have to replace a servo. Of course, what I do before I replace the servo, before I install it, I plug it in to I bought another module that sits on my bench. Because what's cool is none of this is inside the droid. All this code stuff is in this laptop, which means that any Easy Robot controller, once it's interfaced over Wi-Fi, knows exactly what to do. Any of them. So it's not about flashing it. It's not about uploading the code. It's not about jumping into Arduino and making some changes and compiling and then shooting it over, like on the rest of the stuff. Anything I plug into this, I can slave into any Easy Robot piece with the software, if I have the right access code. Because each one, you can set a pin on it. Wi-Fi is secured. If you guys look on your phones right now, you'll see a hub that says Little Buddy. And that's R2. That's his access point. Yes, sir?
So are you saying nothing's saved on the controller, so you have to have a laptop nearby?
Yeah, so that's what this is for. The surface. I Velcro it to the inside with industrial Velcro. I actually, this is a COM8 A1 frame, so it has an elevator piece on it. to raise and lower the center leg. I was originally going to go 2-3-2, and then I decided not to because I wanted to put goodies in this because when I had him out and about and I was taking him to hospitals and schools, all the kids are like, what does it do? And when they see stuff come out of him, like, oh my God, it's fantastic. So I was like, all right. So I ditched the whole 2-3-2 idea and decided to use that real estate for something like this. And this just actually Velcros onto the elevator shaft. And then I use the elevator for my batteries. The batteries Velcro onto the elevator on it. So this is how the whole thing works. Now there's so much more you can do with this guy, right? So I'm looking at my time. Okay. I hope nobody cares if we go over a little bit.
Take your time.
Nobody cares. Take your time. All right. So this is how you would actually position multiple servos in a dome and a body by doing this. So anyway, now let's jump out of here for a second. So let's reinitialize R2 here. There we go. My green initialization button is like the emergency abort. If something's going on, he goes back to a home state. And initialize this little button. This is what you're looking at here with this screen. Oh, yeah. Okay, just so you know, that nasty sound you just heard is the front HP HS53 frying. And I'm so ticked off at it, I don't care. So we'll shut that off though So what you're looking at here is EasyV's mobile interface that they have that you can do. The only problem is it only controls one microcontroller. Because what it does is it will, if I take this and port it onto my phone or my Android for control, it won't control R2 completely because it's only going to hook up with one of them. So I could use it to do dome controls or body controls. That's why I have the Surface, because it needs the processing power to be able to run the whole kit and caboodle. But the other reason is that it's not just an Arduino. For example, here we go. Have you guys been looking at R2 in the hallway? You've seen the facial recognition? Anybody seen that? When you walk up to it and you stare at it, and he goes, hey, and he tips his hat and does his thing. Well, this is what R2 is looking at right now, which is why you need to be a little kid. Because the pitch is it's looking forward at the angle. But if you're a little kid and you walk up and look, yeah. And so whenever a blue box goes around it, and well, let me see here. He can see, you might be able to see my face in a blue box, maybe. Can you see me? You gonna do it? Not a lot of lighting. It's lighting enabled, which is why it's been working really well in the hallway. Okay, there's the box. There we go. Okay, so it found me. And if you notice so the way I wrote that is that when he sees the face, his panel goes up, you see the eye looks forward, and he makes a happy sound. So that was it. So when he sees anybody's face, two eyes, doesn't matter what he's doing. So this is what R2 sees. Technically, you can do pictures with it. You could record it. I don't. No, I haven't recorded any of you looking at this. Because it takes up a ton of memory, and I've had him running like 12 hours a day. But it's kind of fun, though. You can play with it. But really, I just use it for that. And it can do object tracking. It can do all kinds of stuff. The versatility of the platform, the reason I was attracted to it is because it can do things that nothing else so far can that we've come up with. Meaning it has interfaces. So say I want to add something to it. So say I want to add a project and go here. And it's like, well, what do you want to do? And it gives you all these things you can add. You can add touch controls, ultrasonic. You can add bridges, more digital, your camera, audio, I2C interface. Gosh, what's another one? Artificial intelligence. You want to configure cognitive movement. You want it to work with Pandora bots. If you want this thing to actually find out if you're happy or sad, it has the ability to do that. So this R2 is truly interactive with people to the point where he can tell if you're smiling or frowning. And it's all because of this interface.
The easy robot interface.
Yep. You know how much it costs?
Yes, that was my next
Like $70.
I'll take it.
No, I'm serious. It's like $70. The robot controller is about 70 or $80, and then it all the standard servos they have, and all you have to do is get it installed and hook it all up, and the software is free to download. You go to Easy Builder, you download this thing. There's a live community on here that is just like us. You got a problem, you can ask the forum. I know there's mics on it. So Mike's playing with it. Anybody else? Okay. So you will? Yeah, they have. So this guy, so I encourage you all to go to easybuilder.com, and you can download EasyBuilder for free. You can play with it and look at it and goof around, and then you can you can buy the hardware from them, and they'll ship it to you. And it runs, you only need 7.5 volts to actually power the microcontroller and the servos on it. That's just a basic thing. So if you want to get a few servos and get an actuator, you can plug it in and you can power the controller. The going as far as I'm on this, it's a little more complicated, and you experiment with it, you learn, because that's all I did. All I did was experiment with it, and I was like, man, I want one of these in the body. How do I do it? And so I got a nano router, a little travel nano router for like 30 or 40 bucks, and that's what's in there. And it's bridging the dome to the body. Yes?
Surface, is the software able to be used on like a Raspberry Pi to save real?
It's a Windows 10 software. It's a Windows-based system on it. So, but you'll probably notice for driving R2, even though it has saber-tooth movement panel control and stuff like that, but that's because this is a Wi-Fi system. So what I've got is I'm using the Shadow MD controller to drive him, and I use this to animate him. So I use two different systems. Now, the pros and cons to that are, well, the con is that I got two things in my hand. But most of us do anyway. We got either two stealth controllers, we've got two shadow controllers, and we're running around. In my case, it's my iPhone with a Xbox 360 app running for the controller. Windows recognizes that as an Xbox 360 thing. If you watch me play with it over the last couple of days, I'm basically just touching my phone and using the virtual joysticks to control the utility arms and all that kind of stuff. And I'm using the shadow to drive. So it's really no different controlling-wise than we are now. However, I am working on a solution. I'm working on merging this with the shadow system. My good friend Jeff sent me a video that's last night. I'm going to try to pull it up here. And it's on YouTube. And it's basically what we're doing is we're writing an app. And EasyBuilder encourages people to improve their product. So they have things called plugins that you can create. And then once you've created a plugin, you submit it and they'll put it on there, and you can make it private or public to what you want to do. So Jeff, who's a good friend of mine, and he's not a builder, he's actually a software engineer, and much smarter than me. He's been working on this and he sent me a video. So I'm going to play it for you because what we're doing is we are looking at merging Shadow with this, meaning that Shadow will send commands via I2C to the EZB, which will then trigger commands off of the PlayStation controller for like hot commands. So like you could have like a simple setup that, okay, I want to have these controls, this, and this with one button push. No more left, right, click, click, left, click, and it's all good. It's like, okay, I know what this is. And as a result, the app we're doing that, I don't know the price on it yet because he's an engineer, so he's doing this, so we're gonna sell the app because it's not part of EasyBuild. It's gonna be like an extra thing. We'll have drop-down menus for every script that you create will port to the phone. So you don't have to update the phone. All you have to do is use a 4-digit code to link in to the software. And then whatever you create on EasyBuilder is going to bridge back over to your phone, and you'll have total access to everything you've done. Right now, what I'm doing is I'm using this Xbox 360 piece, which I have memorized. EasyB went offline because of the interference, probably because of this thing sitting here, because I'm using a Wi-Fi antenna. Basically, you get a Faraday cage here, which is trapping all your stuff inside, which is why the Surface works awesome when it's inside. It is. It's great inside. So what I'm working on is I upgrade his nano router to where I can get an external antenna outside of them for working with some stuff, because I do need to get the antenna outside eventually. But for the most part, I've been running this thing since the beginning. And if you go to my build log and you watch the videos, that's all you're looking at is how I've experimented with this. And you'll see videos where I've got voice activation going as well. R2's voice activation, I shut it off for this because it's just too much going on out in the hallway. But if you look at some of the videos I recently put up, I'm using this to take control of the lifter rotary mech. And in one of my videos, I basically say, R2, take a look around, and the lifter goes right up. And you can actually tell it what you want to say. It's so simple. It's like voice command, type in there, lift or go up, and then it's okay. When you say this, you move that up and you save it. And I could say, I could even say Rocky Bullwinkle. I could type it in there, and if I said Rocky Bullwinkle, it would go up. It's so simple on it because it's Windows based. So that's what we have. So now I'm scared to ask this question. Who's got questions? Yes, sir.
You mentioned the Surface Pro is inside.
Huh?
You mentioned animations on the phone.
Yeah.
And your example was all body animations.
Yep.
Do you need to switch to go to dome animations? How
No.
if all animations are
Yeah. Well, all the animations are in the Surface, all of them, and the what I'm basically doing, I downloaded this thing. It's by Kanomi, so it's Kanomi, and it's basically an app you buy on the App Store for Apple, and it's this. That's all it is. And so what happens is the Easy Robot program in Windows 10 is looking for an Xbox 360 controller, so it has one. So, oh, are we working? Okay. So now it knows, it knows I've got this thing running. So I'm just using this virtual joystick to make it work as I go. And if I push down on it, it's pressure sensitive and it shuts. And then when I do that, he does this. So I programmed it to whenever I close the utility arms, it makes that sound.
One of them's still sticking out.
Is it?
There you go.
There you go. Now he's going to laugh at me. Yeah. He's got attitude. So, yeah. So if I hit now what was cool about this little mobile piece is that when I activated the joystick, when I open up the joystick window, I can say, okay, the joystick has conditions. Like when the button is down, it does something else. When the button is up, it does something else. So I programmed it to when I push the X button, for example, we're going to deploy the welder arm. So welder arm comes up, script sets off the lights. I'm doing a random on-off on the lights. And then I recorded arc welding track, and I just cue the track. When it's done, I conditioned it to say, hey, when you're done, put it away. And that's because I didn't want someone to accidentally, grab it. Or I forget about it. When I first did this, I forgot I had the arms out, and people were like walking into them and stuff. And I cringed. Thank you. That's how I was. I won't tell you how many repairs I had to do. And then the Y button, it does the same thing with that. So let's see here. There we go. So the Y button then deploys that. And then so I've got total control on the dome. I've got total control on the body stuff. And they're all linked together because when you do this in the auto positions, and you do the script manager, there's literally one piece you add, which is a number in the front of everything that tells the Easy Builder program what EasyB it's talking to. So when I push this button, it knows that both EasyBs need to activate, and we're going to run the auto position scripts on both. Because I told it that. I said, when I push this button, that's what you get. And I'm holding it down, but when I let go of it, as long as your phone isn't on a rotation lock. When I let go of it, there you go. There you go. When I let go, it closes on there. I got another one that if I hold it down, it'll run away. That's that one. And when I let go, it closes. So and also I put this in here too, which is kind of fun. So. Big time.
Greetings, exalted ones. I'm Luke
Everyone
Skywalker,
forgets about
and
this
I'm
one.
knight and friend to Captain Scott.
But it is a message.
I seek an audience with your greatness to bargain for Solar's life. As a token of my goodwill, I present you these two droids.
So we put that on there. He's never happy. He's never happy about being given away. So anyway, so that's what it can do. And then on this case, I got my great big button at the top is the emergency abort. You push that and it goes back into initialization, which is essentially the big green button up there. So so that's how this works. And I can control all the different ones independently. I like the data panel open and close. I can open up the UAs. I can close them. I can alternate them. I have are they alternating? I have like a, oh, hey, I forgot. This is another reason that we're going to write this app, because I've got things on here that there aren't enough buttons here to work. So the app will allow me to access one of my favorite things, which is this. Which is basically a slow body wave. And if you got your Arduino on, you activate your thing. And this is where the bot will do all of its things, and all I got to do is, push buttons, and then we got a spinning disco ball. So, oh yeah. Yeah. So, and then the other thing is the control it. So you're like doing a wave and spinning your bot around. It's disorienting actually. On it. So we'll shut that off. So if that's still working, it's going to finish the script and then shut. So is it done? There you go. So that's what you can do with this. And if you're a novice, you can do this. So, but that's what it is. So what other questions do we have here? And then, oh, thank you. Well, I'm just a dude from Ohio who didn't know anything. I just started reading. What's that?
I have a question. Can we bring you home?
Can you take him home? Yeah, there you go. So who's got a question about that? And I'll see if I can answer it. Yeah.
Does it interact with, say, Ryan's light sets for the hollow projectors?
Oh yeah.
Or are you reprogramming it into your setup?
No. It's actually if I go to HP Lighting, and you can see this, I can access all the different HPs using I2C triggers. So I'm basically just sending I2C the Arduino as I go through it. She can do. There's different short circuit ones. I even created one. It's called Stoplight. It basically chases the colors around the HPs, red, yellow, green, because Ryan's code is really sweet on his HP setup. It really is nice. But all I'm doing is I've connected an I2C line from the EZB controller to his Arduino. And I'm triggering it just like you would off of a Shadow or off of a Jedi or a Padawan or anything you want to do to get the code going. It's the same thing. And then I can clear it. And then I have Luke's lightsaber color that I've done. I got to stop that here, bro. So I can do this. I use that in a swirling piece, because I wanted, blue is very calming and soothing, and if a child looked in the eye and it reacted, I wanted something calming and soothing. I did this because not all the kids can hear very well, so they have an audio with the happy and a visual with the panel and the HP. Because I'm trying to think of that stuff. And then you got your little Sith lightsaber, and then I'm still working on this. This is going to eventually be in a Gangnam style sketch where he's like purple on it. So that's, and then you can clear them. And the same thing too, if you're, I did the same thing with a magic panel. We got our magic panel stuff. We can do the, we can clear it, we can disable, we can eye scan. These are all the magic panel animations. Can you see it? Yep. A little bit. We got compress, expand. We have WAG. We have I named some of these like Cylon. I think that actually Cylon's part of it. Alert flash, trace, random fixed. There's lots of animations, and when I got the magic panel, it was a little bit tricky because it would do a couple things, and I messaged Ryan and said, "Hey, here's what I'm trying to do," and he adjusted the code and sent it back to me so that we could do it. And so I really want to throw a thank you to him. I don't think he's in here. Is Ryan in here? All right, he's not here. Ryan's awesome. Filthy McNasty. He's in the back. Ryan, thank you. So, yeah. So there's all the different things it can do. Pixel loop, fade in, fade out. You can do all of it. So all I'm doing is sending I2C to it.
Follow-up question.
Yep.
After Brett's presentation yesterday about the PSIs.
Yeah.
Trying to get everybody to go to serial instead of I2C.
You can do that too.
Okay.
Because you can do send serial. For example, let's do I'll show you how easy that is. So let's go, let's see here. Oh, is it too far? Am I good? Hold on. So let's add a send serial control. This will be fun. I'm not going to save it because I don't want to mess with this con control too much. But see, if we add a project, and we can add this, we would just go to a, actually, here's where you would go. This is how easy this is. You're all going to be like, oh my God, this is so easy. And now the lady who just said I'm awesome and smart is going to be like, he's dumb. Hold on, so let's, to the magic panel, I'm going to add a script, okay? So here's how this works. Let's add a script. So watch this. Oh, what do you want to do? Oh, we got all this stuff. Well, I want to do send serial. There. So what I did, sorry. Yeah, let me back up. So it starts to populate as you're typing. So send, oh gosh, there's a send serial and a send UDP. So we can go send serial. And now all we have to do is fill in the digital port and the baud rate and the data we want to send. So we can do that, and then it will control anything over send serial. And, or I2C. You can do whatever you want with this. So the send serial stuff is how I'm going to get the kangaroo working for the lifter rotary mech. I've got a bottle of Johnny Walker. I'm saving it just for that. So when I get it working. And I'm working with Dimension right now. They're communicating with me on it because I'm trying to figure this out. Because I could use Doug's board for the I2C, and it's a beautiful board because it's I2C command, but I wanted to run a Sabertooth on it, so because I'm familiar with that. So I didn't use the board, I'm just using the Sabertooth, and I'm using a kangaroo to control it. Once I get it figured out, I'll post it on my blog. So, but that's how easy this is. So you just type it in, send serial, and you just start going. So anybody heard like a code monkey? Heard of that before? That's basically like built into it. It's built into it. So that's how a dude from Ohio who had no experience in robotics put his droid together on it. So who's else got a question? Yes, sir.
You mentioned servo pride like today. How often are you replacing equipment?
Oh, well, the HS53, I've had R2 a lot of places. I mean, we go to schools everywhere, and I'm constantly animating them because that's what the kids want to see. I'd say I've probably replaced in the last year in the dome only. The body servos are a little beefier because they're bigger. The HS53 servos, Kevin stopped putting them in his hinges because they're having issues. He does the turniges now. And so I ordered a bunch of them yesterday because they're Metal Gear. The HS53, I'm using the plastic cheapies, and I have a whole bunch of them, so as they fry, they go. To answer your question, I've probably replaced about 5 servos this year, maybe 6. But it's annoying because the dome is very hard to get the angle on the screws once you have the hinge installed to actually get it back in. And the wires obviously are bound, and I've got them all wire tied together and managed. And anytime I do that, I got to unmanage them and then put it back together. However, there's a builder who did a 3D printed wire spool for servos, which is really awesome. And I can't remember the name of it, but it's a free download for 3D printers. And it actually, you coil the wire around it, and you snap the end into the top of the spool, and then you basically can tape the spool with VHP tape right onto the dome next to the servo, and that saves you from having to mess with your wire management. I want to know why they don't have a servo that actually has ends on the case. Why do we gotta have pigtails? What's the point of that? Let's just put an end on the case so you can just get the wire you want, just plug it into the darn servo. Patented by Doug Bickert. And
It's because it limits where you can orient it on a model airplane.
yeah, you're probably right. Who cares about that? I know. These are R2 builders. They need to cater to us.
Well, that just means you need the plug recessed into it. It's still coming out where the cable is
Perfect.
out there. Good.
Patented by him.
Yeah, great part.
Recess the plug it into the case. It's a great idea. I mean, it's the same thing. You'd be a same. So anyway, so that's how you would do that. What's that?
The servos are getting.
Oh, they're the Turniges. They're the 590M, I believe, is the. It's on the carrier. I'll take a look at it. Kevin gave me the code last night. They're Metal Gear, and they're not much more than the HS53s. So I'm excited to switch them out. So, all right. Do you guys want to watch this video with the drop down before it gets? Because I'm running short on time. I think I have an hour, but it's 11:40. When's the next one? Is it 1 something?
1:15.
Oh, heck. Okay, hold on. Can we go just a little longer? Okay, we're going through lunch. Cool. All right, hang on here. Oh, let me get the address for the YouTube video. we're just going to go to YouTube. All right, so we're going to disconnect from R2 here, and we're going to jump onto the Holiday Inn network here. Then they're going to ask me for money. All right, no, it's free.
You connected the conference.
Gotcha. I think we're all right here. Let's see here. Let's just go to...
This is a quick demo of an early alpha of the modus operandi plugin and mobile app. The purpose of the software is to give builders a complete integrated package to unlock the full potential of the Easy Builder platform. I've got an Easy Builder controller with an actuator on one port and a servo on another. This is just a very basic setup to demonstrate the concepts they were developing for this software package. I already have my laptop connected to the Easy Builder controller over the Wi-Fi that's built into the controller, and have my Easy Builder project open with the modus operandi plugin. The screen's a little hard to see, so we're going to edit in a screenshot of that. But you will see that on the display there is a server IP and port, and this is what the app plugin is listening to connect to with your mobile device. You'll also see that there's a display. This is a really early rough display, so we just have a couple buttons on here labeled for the left panel and the right panel. And then we have our assigned scripts. I've just got some really basic scripts set up to move the servo and move the actuator, just to show the concept. I'm going to go ahead and start my receiver. So at this point the plugin is listening, so I'm going to start my mobile app, and we'll go then into our settings. We'll verify that our IP address matches the one on the screen along with the port. We see that the port is different, so I'm going to go ahead and change that to 2002. And then I'm going to connect to the server. We'll see we get a log message update on our plugin showing that we have connected. And if you go to the log on the mobile app itself, it will also show you that you've connected the system. Then I'll go back to my R2 layout, and if I press one of the panel buttons, I will activate either the actuator or the servo. So with the left panel, and as you see, that causes the actuator to extend and then return. And when I hit the right panel, that causes the servo to spin, sleep, and then spin back, just as my script has dictated. I appreciate your interest, and hopefully we'll be able to keep you updated as we continue progress on the application. Thank you.
I will just tell you what I'll do. I'm going to go ahead and put this video in my build log. So if you go to the builders log forums, if you sort by views, my build log is like in the top 10. I think it's like number 9 or something. And I'll just I'm going to post that immediately so that you can take a look at it, and the most recent one.
YouTube red flag took you down.
I know, it took me down. So that's what we'll do. So meanwhile, are there any other questions? And we got something to give away, actually. Any questions? Give me the giveaway. So that's my presentation. Thank you. That's my presentation, Actuators and Ewoks. And if you have any questions, please let me know. If you want to look through the droid a little more, let me know. He's going to be sitting out in the hallway. And again, tomorrow when they do the auction, this is the machine that deploys that, and this has an actuator on it. And I left the linkage off the servo so that it'll travel better in your luggage wherever you're going. And then the bag of all the goodies here, inside here has the spark gap igniter, the Arduino switch to trigger it, and all the other stuff for mounting this and set up with the linkage. So thank you all so much for coming out today. I appreciate it. And